AI is transforming how software testing works. But using AI tools is not the same as using them professionally. The ISTQB Certified Tester Testing with Generative AI certification defines the structured, internationally recognized standard for applying generative AI in testing. It validates your ability to engineer effective prompts, evaluate AI outputs, enhance automation, and integrate AI into real testing workflows. This is more than experimentation. It is professional competence. Stand out. Prove your expertise. Get certified in testing with generative AI.
Well, hello, and a very warm welcome to everybody who's tuning in for this session of the A4Q Summit 2026, and an even warmer welcome to Alex Bremet. Hello, Alex.
Thanks a lot to Debbie for the warm welcome as every time.
Very quick introduction to Alex. I know that some of you have seen Alex present before at the previous A4Q Summit. Alex is working as a managing trainer and ISTQB lead at Servue, who are a well-known training and consulting agency. Alex had 15 years of experience in different roles in IT, and I know, Alex, that you're actually a former head of IT, so you've got broad experience there and a wealth of experience to share. I'm going to get off stage, and Alex is going to talk to everybody about what I think is a fascinating topic, AI-enabled test management, considering the new ISTQB GenAI Syllabus. So some good content there, I know, coming. Very, very quickly, because at the end of the presentation, I will point to a little QR code that will say, vote for best presentation of the A4Q Summit. So we'll remind people to do that. So sit back, everyone. Please stay to the end and pop questions into the chat. If we don't get time to answer them, then don't worry. We will share those separately with Alex and ask him if he can help to respond. Sit back and enjoy. Thank you so much, Alex.
Thanks a lot here. And welcome to AI-enabled test management, what the ISTQB GenAI Syllabus change for test managers. Thank you for joining here this session. But before we can start, Debbie already introduced the Servue, but let's have a quick overview here, what we are doing at the Servue, what I'm doing when I'm not here in this presentation. So Servue is a training and consultant agency for service management. You can see here IT service management, for example, with ITIL, but of course also ISTQB or IREP for requirements engineering. We have here the second big pillar for project management, project, program, or portfolio management. And the third big pillar here will be the agile part with agile methodologies, agile transformation, and a lot of more. And beside here, the upskilling part, we also have here a consulting part where we can help you when you're struggling entering some of these best practices. But let's have a look here. So yesterday, as a preparation here for this presentation, I had a question coming up from myself. When I'm using Google, am I using already AI? And as you can see here, I make a Google search. When I Google something, am I using AI? And you can see here, the quick answer is yes. So when we are talking about AI usage and the change for our organizations, there is so easy to use here AI, even if we are not aware of that in the background, we are using AI, but not only using AI, but also get data into AI. And when we are looking here where the reality is today, you see here our internal data and different public AI services, from example, Google, but also ChatGPT or other services that are very easy to use. So most of these services you can use with only 3 clicks to get here an account, to use it, and unregulated data flow will be here established. And often or sometimes there is not the awareness that with the data I'm putting here into, I'm training here these AI services. And also unauthorized tool usage is as easy as not before. But there is a big of risk when it comes to these shadow AI. The shadow AI refers to the use of generative AI tools or systems within a company without a formal approval, without governance structure enabled these usage or management oversight. And as I said here, it's so easy to use. Let's come to the uncomfortable truth. Even if a company hasn't officially rolled out an AI strategy, a lot of testers today are likely already using public AI chatbots, for example, like ChatGPT, to help them write test cases, analyze requirements faster, get here test data. While this shows initiative, it bypasses all organizational control. So here, one of these risk of shadow AI usage is security and data privacy vulnerabilities. So the core danger here is that the personal or unapproved public AI tools lack the robust security guarantees required by enterprises. So there is a possibility of data breaches. When testers paste sensitive user stories, proprietary code, or confidential test data into the public chatbot, they are effectively leaking company secret. So there is these public models might use that input as training data, leading to severe data privacy breaches. So as a competitor, it could be possible that I get here some very big insight of my competitors because they trained here the AI models by entering very private, confidential data. The second pillar here of a risk is compliance and regulatory issues. So the unauthorized use of GenAI completely undermines a company's compliance effort. Using unvetted tools can violate strict industry standards and legal data protection regulations, such as the GDPR, for example. And it could be coming to a legal consequence of failing to govern how data is processed by AI exposes the entire organization to potential lawsuits and several legal penalties. And the third big pillar of risk here is unclear copyrights and intellectual property. So here, the licensing ambiguity. Many public AI tools operate under terms of service that have unclear licensing agreements regarding the generated output. So the big question is, when I'm getting here input back from these tools, am I the owner? Can I use it here for my products and so on? So we have to move here from an ad hoc usage of AI to a strategic AI adoption. So you cannot simply let testers figure out AI on their own. There is no learning by doing this topic without some guidances here, some oversight. A clear strategy and concrete steps are absolutely necessary to eliminate the risk of shadow AI and turn GenAI into secure, value-driven asset. So we have to define measurable goals. The roadmap must begin by defining clear, measurable test objectives for GenAI usage. Instead of just using AI, the goals should be tangible, such as increasing test productivity, shortening test cycles, or improving overall test quality. As an advanced test manager, you should apply the SMART methodology to define these goals, so you can here have specific, measurable, achievable, realistic, and time-bound goals. The second part here will be establishing procedural guardrails, compliance, and also ethics is here a very big problem or a very big concern. So the roadmap must include the creation of procedural guidelines to ensure alignment with legal standards and ethical guidelines. We need clear rules. This means establishing explicit rules for how the team handles sensitive data when interacting with large language models. And the last part here will be the transparency requirements. The strategy must enforce transparency. So everybody must be aware of these steps. Everybody must be aware of these guardrails, such as implementing rules to clearly label which test artifacts were generated by AI and establishing quality gates where humans review the AI's output. So let's have a look here to the role of the test management. So we as a test manager, we need to lead your hybrid teams consisting of humans, but also AI. In the traditional setting, the test manager is responsible for the entire test process and the human test team. However, the introduction of GenAI expands this scope significantly. Test managers are no longer just leaders of human testers. They must now coordinate the development of generative AI supported test agents. New management skills. So we need new skills as a test manager. The shift requires entirely new capabilities to effectively lead hybrid teams that consist of both human expert and generative AI tools. And on the other side, we need here a balancing capabilities. A key responsibility is finding the right balance between human intuition and AI efficiency. The test manager must ensure that the team does not blindly rely on AI, but rather retains their traditional testing competencies while building new AI knowledge and therefore AI competencies. Evolving the test strategy and risk management. So updating core responsibility, when we are looking back to the traditional test manager, they are formulating the test strategy, plans test activities, and manage test risk. With GenAI, these core tasks are evolving. So on the next slides, we want to have a look here into the shift. We will always have a look here to the traditional task we have as a test manager and what are the new challenges of the new task with GenAI usage. The scope is now expanded to include the development of an explicitly AI-based test strategy and the implementation of AI-based risk management. So there will also changes in new upcoming risk and risk management. Just as they track human progress, test managers must now actively monitor and control AI-based test processes to ensure they align with the project's quality goals and timelines. We need to establish here AI governance and clear guardrails. So we have to define the rules here to prevent the dangers of shadow AI. Mentioned earlier, the test manager is responsible for establishing clear AI governance frameworks for specific use cases within the team. Align with standards. This means taking accountability for how the AI is used, ensuring that AI tools comply with organizational goals, security requirements, and regulatory standards. On the other side, we have to guide the evolution of the tester's role. So not only there are shifts in the role of the test manager, but on the other hand, also the tester role must be evolving here from creators to validators. Test management must guide your team through a fundamental role change. Testers are evolving from specialists who manually design and execute tests into IA-supported specialists. There will be also not only a shift in competencies, but there will be coming up new competencies without having a lack of the traditional competencies. As a manager, you are responsible for developing the competencies of your team members. For GenAI, this means training your testers to combine their domain expertise with new skills such as steering AI tools, critically reviewing AI-generated test assets, refining prompts, and maintaining shared prompt libraries for the team. So, as I stated before, we want to have a look here to the classic test management. There is only missing here a trademark. I love here this classic approach. Also in other best practice frameworks, there will be over the time a shift. And I love to say here classic IT service management. In this case, classic test management. And you see here the classic test management role. You will have a lot of things to keep in mind here. We want to focus on this slide on two things: the project test strategy on the left side and making tool decisions and ROI, return on investment evaluations. Let's start here with formulating the project test strategy. When we are talking about this test strategy, we have the need of contextual alignment. A core responsibility of an advanced test manager is to define a project test strategy that directly aligns with the overarching organizational test strategy on the one hand, and the specific project context on the other side. Selecting the right best fitting test approach, the test manager is responsible for making critical decisions regarding the test approach, which includes selecting and combining the appropriate test levels, test types, and both static and dynamic test technique to ensure maximum efficiency and effectiveness. We have to analyze the influencing factors here. The strategy cannot be created in a vacuum and must be tailored by analyzing various constraints such as the project domain, regulatory requirements, budget and time limitations, the specific software development life cycle being used, and the availability of test resources and test data. We also have to define in the project test strategy smart objectives. So a crucial part of strategic planning is define clear, measurable test objectives. And when we are not defining them measurable, we can't achieve them every time when we are looking if we achieve these objectives. This is here based on our feelings, but not on an objective measurement criteria. So one thing I mentioned earlier is here the SMART method. On the other side, we have to make tool decisions and a return on investment evaluation. And here we have to make a risk, cost, and benefit analysis for the tool selection. I must always be driven by a thorough analysis of risk, cost, and benefits, so we can ensure here a positive return on investment for the organization as a whole. Evaluating the software landscape before introducing a new tool, test managers must assess the existing software landscape and tool strategy to ensure that these new tools we want to integrate here seamlessly can be integrated without conflicting with restricted vendors or existing infrastructure. Financial and regulatory consideration. Tool decisions required weighing financial aspect on the one hand, such as initial acquisition cost, training expenses, and recurring license and maintenance fee. So we are talking about these total cost of ownership here. Against, on the other hand, regulatory requirements, IT security standards, and the specific functional needs of the stakeholders. And the last part is managing the tool lifecycle. The test manager's responsibility extends beyond just buying a tool. It involves overseeing its entire life cycle, which includes running a proof of concept during the acquisition phase, establishing proper support and maintenance guidelines, and eventually managing the tool's retirement. So you will see here a shift when we are using are implementing GenAI, there is a shift, developing an explicit AI-based test strategy. So there is a new strategic layer coming up. With the integration of generative AI, the scope of the test manager expands significantly. You're no longer just planning human test activities. You must now develop an explicitly AI-based test strategy. We need to address AI constraints. This modernized strategy must proactively address new variables, such as what input data is safe to use in prompts, how to handle the non-deterministic nature of AI, and how to ensure compliance with AI-specific regulations and standards like the EU AI Act or the NIST AI Risk Management Framework. We need to define specific GenAI test objectives. While classic strategies rely on standard project goals, a GenAI test strategy requiring defining clear, measurable objectives specifically for the AI's performance. Tangible AI value on the other side, the strategy must articulate explicitly why AI is being used, setting goals such as increasing overall test productivity, dramatically shortening test cycles, or improving test quality through better coverage analysis. We need to embed here a model selection into our strategic planning. So we have here a lot of different models. For example, we make a difference between large language models and small language models. And a fundamental change in the strategic planning is the shift from just choosing software tools to selecting the right brains for the operations. So we need to outline the criteria for selecting here a LLM over a SLM or vice versa. Cost versus capability. So on the other side, AI tool usage costs a lot of money. So test manager must strategically weigh the capabilities of these models against the recurring operational cost, such as the volume of tokens used for input-output and the frequency of test execution. Let's have another look here, or a further look to the shift in the risk. So we have to define product risk and the goal of testing. The definition of a product risk is defined as a potential situation where quality problems might exist within a product. One of the mitigation strategies we can apply here is testing as risk mitigation. In classic test management, testing is a primary activity for mitigating these product risks. If tests uncover defects, the test is mitigated because the team has the opportunity to fix them before this is released. If no defects are found, it indicates that the product risk is lower than initially expected. Assessing the risk level. So the classic formula is here likelihood versus impact. So once the product risks are identified, the test manager must determine their exact risk level by evaluating these dimension: likelihood of the defect occurring, and the impact or damage if the risk is occurred. Evaluating the impact when assessing the potential damage of a product risk, the test manager must weigh several business factors, including potential loss of revenue, damage to the company's reputation, which is often very hard to quantify here, civil or criminal legal sanctions, and the criticality of the affected features. As stated, one of the mitigation is here through testing, and in ISTQB we are talking about the proportional testing approach. The fundamental principle of risk-based testing is that the effort spent on developing and executing tests must be strictly proportional to the identified risk level. Higher risk product areas must be tested earlier in the life cycle and with much more rigorous test procedures. But now we have here new risk coming up. There is a paradigm shift in risk. Generative AI introduces entirely new categories of product and quality risk. As test managers, you must update your risk register to account for the fact that LLMs are probabilistically driven, not rule-based. So there are three big risks according to the AI output. Hallucination is one of these. This occurs when the LLM generates an output that seems factually correct and highly plausible, but is actually false or entirely invented. In a test context, the AI might generate test cases for non-existing acceptance criteria or write automated test scripts that call functions that do not exist in your code base. Reasoning errors. LLMs do not possess true logical reason. They rely on patterns recognition. This leads to reasoning errors where the AI misinterprets cause and effect relationships of conditional logic. This is especially dangerous for test managers when using AI for logical problem-solving tasks, such as estimating test effort or prioritizing complex test cases. And the third one here is the bias. AI models inherit biases from their massive training data sets. For testers, this means that the AI might generate skewed genetic test data that underpresents certain user demographics or ignores critical non-English edge cases, leading to blind spots in your test coverage. So another challenge here is that AI tools are non-determinism. Unpredictable outcomes, unlikely classical test automation scripts, which are deterministic, LLMs exhibit non-deterministic behavior. You can submit the exact same prompt twice and get two completely different test cases. So there are mitigating strategies for this. We need to build reliable test automation. Therefore, test managers must implement mitigation strategies such as lowering the model's temperature parameter to reduce randomness or setting a random seed to force the LLM to generate more reproducible results. We have the need for a formal AI governance. So generative AI introduces significant risk like hallucination, security vulnerabilities, and environmental impact. To manage these systematically, test managers cannot solely rely on ad hoc internal rules. We have to align here with global frameworks. So in the ISTQB syllabus, there is explicitly stated that test managers must integrate established AI regulation standard and best practices framework into their test strategy. There will be 4 different standards named. On the one side, we have the ISO 42001. This is a primary international standard for information technology, artificial intelligence management system. As a test manager, you use the standard to establish formal requirements for managing AI systems within your organization. It provides the guardrails to ensure that your use of GenAI for testing strictly follows recommended practices, which ultimately promotes consistency and reliability across your test team. The second one is here, the ISO 23053, ensuring data quality and transparency. This standard provides a framework specifically for AI systems using machine learning, focusing heavily on the AI lifecycle, fault tolerance, and transparency. Then we have the mentioned EU AI Act. So the EU AI Act is binding regulation that creates a legal framework AI risks and classifies AI applications based on their specific risk level. And the last one is here the NIST AI risk management framework developed in the USA. The NIST AI provides comprehensive guidelines for AI risk management with a strong emphasis on fairness, transparency, and security. Besides these mentioned standards, there is another important part for the test managers: staying updated. The AI landscape is moving incredibly fast. The GenAI syllabus makes it clear that it is a fundamental responsibility for test managers to continuously stay informed about the evolution of these regulations, national laws, and best practices. One of the foundational tasks for a test manager is monitoring, control, and metrics. On a classic test management, establishing a framework for monitoring and control is essential. As the management says goes, what gets measured gets done. The test manager must define specific targets and use test metrics as indicators to answer the fundamental questions: are we actually achieving our test objectives? On the test monitoring, we have a continuous observation. This is an ongoing continuous activity throughout the project. It involves systematically collecting and recording test results. And then we have the test control, taking corrective actions. While monitoring is about gathering data, control is about taking action. Test control constantly compares the actual progress against the predefined exit criteria and triggers corrective actions if the project falls behind. And there's a third big part why we are getting metrics here beside the monitoring and the control. This is the strategic use. There are 3 categories of metrics to evaluate the testing effort effectively. Test managers traditionally categorize these 3 distinct areas. Project metrics, where we are measuring the progress, such as the percentage of executed, passed, or failed tests. The product metrics, where we are measuring the actual quality attributes, and the process metric, making sure that we are efficiently and effectively going through our test process. On the other side, and I like here the quote from Peter Drucker: if you can't measure it, you can't improve it. We can use here these process metrics to getting better over the time. And the last one is here this transparent stakeholder reporting. We have to translate here these raw data for the business, for our business stakeholders, to enabling here decision making. For example, to enabling a decision if a release has the right quality so that we can go to the release, or do we have to postpone here the release and have to rework. Yeah, we have a shift for the test manager here from a manual data crunching to insight generation. Traditional test monitoring requires test managers to manually retrieve and analyze massive amounts of often unstructured data scattered across various test management tools. So generative AI completely shifts this dynamic, because large language models excel at natural language processing. They can directly ingest massive amounts of unstructured data, like bug reports, test logs, raw data execution, and automatically synthesize it into actionable metrics. We don't look only in the past. We want to have a look into the future now. Traditional metrics tell you what has happened. GenAI introduced predictive monitoring by analyzing historical defect trends and current test progression. The AI can forecast potential risk and schedule deviations before they become critical. So that's why we need here new metrics from our traditional set of metrics. Traditional test automation is deterministic, meaning the same input always yields the same output. Generative AI is non-deterministic, so evaluating its performance requires a new set of metrics based on statistically relevant data rather than single execution. We have here quality, accuracy, precision, and recall. So the accuracy measures the overall correctness. For example, to what degree do the AI generates test cases cover all the specified requirements when compared to tests written by human experts? Precision evaluates exactness. For instance, how well do we generate test cases correctly, identifies anomalies without creating false alarms? The recall measures completeness. Does the AI identify all relevant instances, such as covering all valid and invalid equivalence classes for a specific data category? Are the generated test cases aligned with your specific test bases? And do they correctly integrate unique domain requirements? Will be here the relevance and context appropriateness. And we have the diversity as the last one. Does the AI cover a wide range of user behaviors and edge cases, or does it simply generate repetitive scenarios? There is another important part. This is here the return on investment. We need here a clear business case for our AI tools, for the AI usage. Time efficiency will be, in the most cases, the ultimate ROI metric. You must measure the time it takes the AI to generate the test, including the time humans spend reviewing and fixing it, and compare it against the time it would take a human tester to write the equivalent test manually. And we have a shift in the team development as well. On the classical test management, there will be 4 areas of competency. The 4 pillars are here: the professional or technical competency, or testing techniques, for example, domain knowledge, and tool expertise. The methodological competencies, analytical skills, and independent problem solving, for example, social competencies, communication, conflict resolution, and teamwork. And the last pillar here is the individual or self-competency, resilience, self-management, and willingness to learn. We have, as a test manager, identify skill gaps. We have to assess the baseline. We have to have a look here. How can we solve the gaps between the given skill set and the needed skill set here in these 4 pillars for our project? And we have to managing the motivation and team dynamics. Motivators versus hygiene factors is mentioned here in the test manager syllabus. On the other side, there is an evolution of the role of the test manager, but also in the role of the testers. So we need new competency skills, prompt engineering mastery, for example. The testers need to understand the technical limitations of LLMs, such as context window size, and be able to evaluate non-deterministic AI outputs using specific metrics. On the other side, the test manager role is also evolving. We need to lead here a hybrid team where we managing not only humans, but also AI chatbots, AI tools. And to get here these new skills, to put here these new skills into the wide organization, there is a hint to use here communities of practice. We should enable here continuous peer learning, and we should sharing knowledge. So the team must meet regularly to share successful Gen AI use cases, discuss challenges, and collectively build and maintain shared prompt pattern libraries. So first of all, let me say here, thank you for listening. You'll see here there are a lot of new challenges, a lot of new skills, a lot of new tasks coming up with the usage of Gen AI for the test management.
Thank you very much, Alex, for that insight, which I'm sure will be very helpful to anybody who's responsible for test management and thinking about Gen AI. Let's see if we've got some questions. We're really close to time, but let's see if we can fit a couple in. How can we prevent our testers from using shadow AI if we currently do not have the budget for a large enterprise AI solution?
It's a very interesting thing here, and for one, as a test manager, you cannot simply ignore the shadow AI. So ignorance is here not the right start. We have to make here some guardrails. We have to have a look here into some governance approaches, which currently is not the high budget task. On the other side, there could be, even for small budget, tools that we can use here. For example, a small language model, which are purposefully designed for smaller and more efficient usage case. And this could be here a good start to evolving over the time to show the organization the return on investment here on the other hand.
Thank you. Let's go for one more question, Alex. Generative AI is non-deterministic and often provides different answers to the same prompt. How can I, as a test manager, establish reliable metrics or automated tests?
Yeah, this is here indeed a major challenge for the organization. So to make the model's behavior more predictable, we have to adjust, or we can adjust, the model's temperature. So here is a degree where we have a parameter that controls the randomness and the creativity of our models. Because the models operate probabilistically, you cannot evaluate them based on a single execution. Instead, you must systemically measure the quality of the AI's output against a specific goal using specialized metrics. These must be include here the accuracy, precision, and the recall or sensitivity.
Let's try one more, Alex. I'm just watching the clock, but let's try one more. Yes. When deciding whether to buy a commercial Gen AI testing tool or build one ourselves, what specific costs and factors must we evaluate?
So we have here similar cost in our traditional tooling evaluation. So there are a classical cost-benefit analysis will be still necessary. But Gen AI will change here the variables. Now, if you evaluate commercial tools, you must specifically look at the recurring operational costs. There is not only the initial buying in cost or cost for training, but we will have here also usage fees, cost per input, cost per output, cost per tokens. And we have to assess here the model's potential for fine-tuning on a specific company data. So if you choose to build a custom tool in-house to maximize data privacy, your organization must adopt LLM ops, so the large language model operation. This means you are responsible for the ongoing cost of computing resources, data storage, and the continuous monitoring that is required to maintain the model in our production. So here are coming new metrics, new cost into the sum.
Thank you. Good advice. We've reached the end of our time, Alex. I'm so sorry, but a huge thank you to you. Can I have the little QR code at the top of the screen, please? There it is. To vote for Alex for the presentation, best presentation of the A4Q Summit. big thank you again to everyone for tuning in. Big thank you to Alex, and please hang around for some more sessions in the A4Q Testing Summit. I know there's some good things to come. Thanks again, Alex.
Thanks a lot, you too.
Generative AI is transforming how software testing works. But using AI tools is not the same as using them professionally. The ISTQB Certified Tester Testing with Generative AI certification defines the structured, internationally recognized standard for applying generative AI in testing. It validates your ability to engineer effective prompts, evaluate AI outputs, enhance automation, and integrate AI into real testing workflows. This is more than experimentation. It is professional competence. Stand out. Prove your expertise. Get certified in testing with generative AI.